Hi, and welcome back. In this next module, we're going to talk about how vSphere with Tanzu and the NSX integration works together when we're driving our new containerized workloads. So, the objectives of this lesson is we want to go over a very key component that is the integration point between our Kubernetes infrastructure in NSXT. And what that is this thing called the NCP or the NSX container plugin. We're going to go over the architecture of where that's at and what it's doing. We're going to explain to you how the supervisor cluster or the control plane VMs, their network topology works. And then we're going to take a look specifically at some Kubernetes services. And finally, we're going to round it up with taking a look at Kubernetes network policies or our security pieces. So let's go ahead and get started. The first one is the NCP, the NSX container plugin. As you can see in the picture here, we're illustrating that we've got three control plane VMs. The supervisor or control plane VMs are running a series of services, and some of those services can actually be running as pods. We have three of them to be able to have a degree of high availability and also for higher capacity. One of those services running in one of the control plane VMs, the one that's active, is this piece called the NCP. And what the NCP is doing is he's listening for certain types of objects or primitives that are being created by the users of the Kubernetes clusters. The specific ones that we're calling out to you is if somebody created a namespace, or they deployed a pod, or they created a service like a load balancer or an ingress controller, or they created or applied a network policy. What's happening is the NCP here is notified about those objects. Now, I need to point out to you, it's just not creating, but it's also if you update one of those objects or you delete one of those objects, the NCP is going to make the appropriate API calls over to the NSX manager, and he'll either create, update the configuration, or delete the corresponding object over in NSX. Those corresponding objects are listed out here for you. So a namespace results in us creating a new NSX segment. Deploying a pod, well, there's a few things we've got to do in NSX. Most importantly, besides assigning a pod IP address, we got to get a port created on the segment for it to plug into what you know is a VIF. It's actually now a CIF, a container interface. When you create a service, we're going to come over to the NSX manager and set up a new virtual server. A new IP address will be allocated to it with the appropriately programming of the rules of to which protocol and which ports we want it to listen on. And if we create a network policy, that's going to result in us over here getting a firewall sections, actually two of them created with the appropriate firewall rules to support what we've defined in our network policy. I want to point out to you that the integration of this style with the NCP is not only used here, but it's also used in our other solution, what we used to call Enterprise PKS, which is now called Tanzu Kubernetes Grid Integrated. We also use it in OpenStack, and even competing Kubernetes solutions will also look at using NSX as their networking implementation for their Kubernetes deployment, and the same NCP style of integration is occurring in their solutions. So, when you first enabled the workload platform and we started creating those supervisor control plane VMs, one of the things that happened before that is we went over to NSX and we created a series of segments inside NSX. These segments are being used by your vSphere with Tanzu implementation. Several of them inside here have different pods that are being deployed on the control plane VMs that will be plugged into those individual segments. Each of these segments is over here connected to a T1 router, which in turn is going to be connected over here to a T0 router, which will eventually come on over to your physical network up here. You could see all of those objects by going into the NSX graphical user interface, and you could see here I've got one T0 router, I've got one T1 router. So this is right after you enabled the feature and you have nothing else going on in NSX. You could see we created a total of 14 segments, including 13 NAT rules that are defined. This is a little bit of a call out on when you should expect to see additional segments getting created over in NSX. The first one over here is the segment that corresponds to if you enabled Harbor as your image registry. We're going to create a new segment, and the corresponding Harbor pods will be plugged into that specific segment. Here's the namespaces. You just did the namespace lab. We're illustrating here two additional namespaces, O2 and O3. But as you go to the vSphere client and you create the vSphere with Tanzu namespace, that results in a Kubernetes namespace, which in turn is resulting in a new segment created. Each namespace is going to be its own layer 2 broadcast domain. Finally, we haven't gotten there yet, but since we're talking about the additional segments, when you deploy any TKG clusters, each TKG cluster is going to get its own segment created down here, and that cluster will have its own layer 2 broadcast domain. This is a topology picture of what it actually results in. And you could see inside here when we're looking at our supervisor cluster networking topology, here is my management network. And when you enabled the feature of your workload management platform, you specified that management network for your control plane VMs to be plugged into, and you gave it a block of 5 IP addresses that these control plane VMs would be using. The control plane VMs, or the supervisor VMs, actually have 2 NICs in them. The second NIC is coming up here to the control plane VM segments that are going to correspond to the different services. Each namespace that I create, in turn, any pods that I deploy there, they'll be plugged into that namespace. And we're just illustrating a second one over here for you. All of these, as you can see, are coming out to a T1 gateway, which in turn is going to the T0 and then up to your physical network. As we enable this feature on more vSphere clusters that we want to enable with the vSphere with Tanzu feature, as you can see up here, I'm illustrating another cluster B. So this would be a different vSphere cluster that I want to enable this feature on. He's going to get each new cluster that I do that to is going to get a new T1 router created just for him. And then in turn, it would have its own segments that correspond specifically to that. But by default, it's going to share the same T0 router. When you're investigating inside NSXT, your containerized workloads are first-class citizens there. So you're actually going to have underneath inventory, you're going to have a link that's going to show you all of the containers that are running with a container interface inside NSXT. I could filter out those containers quickly by up on the filter thing, just typing in the specific namespace that I want to see, or it would list all of them. If I want to actually see the pods that are plugged into it, or the services, or the networking that's going on, these three numbers over here, are all clickable. So if I clicked on my pods here, it would take me to a dialog box that's going to list the 3 pods that are plugged into this segment. I could see the IP address that's attached to those pods, and I can also check the connectivity status to them here by seeing green up, we're good. So as you deploy additional pods, the common replica count that you're going to be using in pods for higher availability and a higher degree of scalability is you're typically going to be deploying 3. That would give us the ability to have some component in my infrastructure fail and still have 2 of them remaining available to service my production workloads. So here's the typical replica count down here. I've got 3 of my pods deployed. Well, somebody out here on the, let's say, corporate LAN segment or on the internet wants to access. They're not really worried about which one. They just want to access your application. Well, how are we going to route traffic to these pods? And to provide that external access, you're going to end up using a Kubernetes primitive of type service. And specifically, this spec is calling for a load balancer. So the load balancer is going to have an ingress IP address, which should be accessible from your external corporate LAN or maybe the public internet. And then in turn, it's going to route that traffic to whatever you specified here is the selector. This selector would be selecting these pods back here. What are we listening on to? Well, we're going to tell the load balancer to listen on port 80, and then we're going to tell it to forward the traffic to the pods on port 80. You could see that this is done by using the kubectl CLI, and we're using a little technique here in the kubectl command. You can actually do a kubectl get multiple different object types by simply stringing a comma between them. This is doing both the getting my pods as well as getting a service. You could see the 3 pods here. I could see that I've got a type load balancer, and that is the external address that it's actually listening on. This is one way to see it inside kubectl. I can also see that inside NSXT. So I've gone to my networking tab of NSXT, came down and selected my load balancers, gone to my virtual servers. Right here's that virtual server, and this IP address corresponds to what you're seeing in the kubectl CLI. So this begins the beginning part for us of this integration. We could keep digging a little bit further. If I went over to my server pool, I could actually see the 3 pods here as well. From a topology viewpoint, it would look something like this. So to answer the question, how did we do this before? We defined a service here. That service was of type load balancer, and the NCP plugin actually went over when it saw that and created the corresponding object over in NSXT. So this is a good breaking point. Why don't you go ahead, stretch your legs, and take a break, come back, and we're going to continue on with the additional primitive objects that NCP is listening to. And our next one's going to be a really important feature is the network policy. So I'll see you when you return.